All right, here we go. And now, really, what we're doing now at the end of Module 3 here is we're putting it all together. You spent Module 9 doing kind of the big three: translations, reflections, rotations, and now in Mod 10 we've been doing dilations. So now we can kind of see how this all gets put together to do all of these transformations. Okay, so what I need you to do is make sure you've got something to write with. If you want your calculator, fine and dandy. This is page 327. 327. And get ready to go. Pause the video whenever you need to. And we're going to start transforming the daylights out of this gorgeous rectangle. Here we go. Okay. So we're going to start with this green rectangle that's in your book. And the first thing we're going to do is perform this. Now, this is all written algebraically, so we kind of have to think, okay, what does this mean? This means when you're adding to x 7 units, that is a slide to the right 7. And since we're subtracting from the y, then we're going down 2. So I need you to take each one of these original vertex points and translate it 7 to the right and down 2. Pause the video as you need to in order to make this happen, okay? So if I'm at -6, 1, 2, 3, 4, 5, 6, 7. Okay, here. Oh, wait, that's not right because I have to go vertically as well. See, I needed to erase some of this gunk anyway. All right, so back on track to do A. Here we go. 7 to the right and then down 2. 7 to the right. 1, 2, 3, 4, 5, 6, 7, down 2. Here we go. Draw your new rectangle. This is A. Okay. All right. Now, notice what it is asking us to do is sometimes, especially when you animate things, you need to translate them, reflect them, rotate them, sometimes dilate them. Okay, so what we're going to do is apply this sequence, and each transformation is applied to the image of the previous one, not back to the original. Excuse me. So we've got this one done now. We feel pretty confident. Now we're going to pick it up at A and perform this transformation. I'm going to change color while you look at that. This says X stays the same, but my Y values are going to be the opposite. Okay, so keep in mind, these points right now are at, say, 1, 2, 3, 1, 4. This is 1, 6. I'm going to keep my X values the same at 1, but they're going to become -4, 1, 2, 3, 4, and -6. Aha, that is a reflection across the x-axis. The x values stayed the same. Your y values become the opposite. So over here, where I am at +5, 4 and +5, 6, you'll still be at +5, but you're going to drop 4. Go down 4, down 6. There's B. Okay. Now is when things sometimes get a little tricky. It says we're going to rotate 90 degrees. We're going to go clockwise about the origin. Okay, so it's like you've got to turn your book and take it 1/4 turn clockwise. Now, it's a little harder to do for me because I am just looking at this sucker and I basically have to envision what it looks like here. So let's take this first corner on your rectangle. Right now, this is at 1, -4. Okay, when you turn it 90 degrees clockwise, what's going to happen is now it looks like it's at -4, -1, 2, 3, 4, like this. Okay, so when you swing it or rotate it this way, okay, instead of being +1, -4, it's going to end up being -4, -1. This point down here, which is at +1, -6, is going to end up swinging up this way and is going to be at -6, -1. Let's talk about these two. Do one at a time if you need to, and just pause, turn your book, get the coordinates, and go back and sketch it in there. Right now, this is at 1, 2, 3, 4, 5, -4. And here's what's going to happen. When you turn it, now it's going to be at -4, -5. 1, 2, 3, -4. 1, 2, 3, 4, 5. Like this. -4, -5. And this last guy is going to end up being, right now it is at 1, 2, 3, 4, 5, -6. This guy is going to end up being at -6, -5 over here. Here is this transformation C. Whew. Jinkies, okay? All right, next. Oh my goodness. So now we're back to a nice, simple translation. And basically what we're going to do is add 5 to x. So that means shift to the right 5. Add 3 to the y values means go up 3. Okay, so to the right 5, up 3. I'm going to start with this corner. 1, 2, 3, 4, 5, up 2, 3. Take this one. 1, 2, 3, 4, 5, up 2, 3. Bottom of the rectangle, 1, 2, 3, 4, 5, up 2, 3. Same thing with this one. 1, 2, 3, 4, 5, up 2, 3. Everything should be lining up nice and neatly at the same level because it's still making a rectangle. Hey, look at that. It's perfectly positioned at the origin or centered about the origin. Now, this very last one that we're going to do, take a look. This says take your x and y coordinates and dilate them by a scale factor of 3. So take everything times 3. So this first point up here, which is at 1, 2, multiply everything by 3. 1, 2, 3. 1, 2, 3, 4, 5, 6, right there. 3, 6. Take this guy, which right now is at 1, -2, and multiply both coordinates by 3. 1, 2, 3. 1, 2, 3, 4, 5, 6, right here. If you want to connect that side right away, go ahead. Do the same thing with building these ones out with a scale factor of 3. -1, 2 becomes -3, 6. Zoom. And if everything goes right, this guy should line up exactly from -1, -2, multiplying both by 3 gives you -3, -6. And it lines up properly, so it looks like I graphed it. That should be your final one for transformation E. All right, so list the coordinates of this new rectangle. All right, and we've got the 4 corners. Go ahead and get those written down and then check as soon as I get mine in there. Go ahead. All right, 3s and 6s in this particular combination is where you should end up. So now when I tell you, I want you to compare the following attributes, shape, size, and angle measures of the corresponding parts of our final one here, rectangle E, to the original one, which was this original green one. I'll make stripes there, okay? The shape, it's still a rectangle. The size of the rectangle, although has been changed, this has been dilated by a scale factor of 3. As far as angle measurements, it's still a rectangle. All of my corresponding angles are still all 90 degrees. So those are still congruent. So you can either write the word, if you want to say the measures are the same instead of using the word congruent, that works. And if you want to use the symbol, the way us super efficient shorthand writing mathematicians are, you can use the symbol for congruence, okay? So this becomes one giant, oh my goodness, put this all together kind of puzzle as you're looking at all of these different transformations happening at once. Cool. All right, so let's look back and think about this. Which transformation was the dilation? So if you look back there, the one that was asking you to impose that scale factor was step E. So you should say step E. And you can say because it changed the size of the rectangle by a scale factor of 3. Of the rectangle. All right, a sequence of transformations containing a single dilation is applied to the figure. Are the original figure and its final image congruent? No. If there is one dilation in there, you changed the size of the figure. And so because of that, we have to say no. A dilation changes the size. That's an H, by the way, of the figure. There we go. I guess the only one that really wouldn't change anything is if the dilation had a scale factor of 1. But for most of these, I'm going to go ahead and assume that, yeah, they mean a scale factor that's different from 1. Okay? All right. Two figures are similar if one can be obtained from the other by a sequence of translations, reflections, rotations, dilations. All right. Similar figures have the same shape, but probably are different sizes. The only way that it would be congruent and not a different size if you either didn't have a dilation or if your so-called dilation had a scale factor of 1. So let's see. We want to go from A. We're going to start at A and get to B. All right. And then tell whether they're congruent. Okay. Well, I can tell you right now, not congruent. I can tell immediately they're different sizes. Duh. Are they similar? Well, that's going to take some work. All right. Let's take a look at our starting square. All right. I'm telling you that's a square because number 1, I just looked, every single side is 2. And because it's on this coordinate plane and on this graph grid, every angle is 90, so it's a square. Side length is 2. Take a look at our ending post image or image here. And this also is a square. 1, 2, 3, 4. 1, 2, 3, 4. All right. So let's see. I think all we need to do basically is we need to make it bigger. So we need to do a dilation to go from a 2-sided square to a 4-sided square. So we're going to dilate it and make it bigger. Go ahead and write your notes here because all in this word here, it's blah, 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 writing the notation in words. And I like to shorten it up a little bit. So what we're going to do to A is we're going to double each side. So we're going to take every point xy using a scale factor of 2 and make it a 2 times x and 2 times y. That will make each side a side length of 4. Now we'd better do this so we can see what it looks like. All right, because then we've got to get it to land exactly in the position where B is. So This is the 0.11. When I transform it or dilate it by a scale factor of 2, that'll be 2, 2. Negative 1, 1 will become negative 2, 2 up here. This corner down here, which was at negative 1, is going to expand or dilate out there. And guess what? 1, negative 1, this guy ends up being 2, negative 2 down here. Go ahead and draw this one because this is the intermediate step, and it's going to help us see what incarnation we need to do here. Okay, so I dilated it, made it the same size. Now we've got to get this point from here up to here, this point up there, this guy here, and this guy here. And since it's a square, I don't have to worry about spinning it or flipping it at all. So notice it said no reflection, no rotation. We've just got to slide that puppy up there. So let's start counting. Now I'm going to have to shift, let's see, 1, 2, 3, 4 to the right, 1, 2, 3, 4, 5, 6 up. So then you would take your transformed point from this after the dilation, and then you're going to take your x values and shift it 4 to the right, add 4, and go up 6 to the y coordinate. That's your vertical, up 6. To the right 4, up 6. Boom. There you go. And notice that's exactly what they have there. All right. Whew. All right. So you're doing things visually and then having to write it algebraically. All right. Let's look at a couple more situations here. Okay. Ooh, turn the page. Look at this thing. Cool. This is like a pentagon that kind of has a concaved section there. All right. Now they're saying do it 2 ways. Do once with a reflection and then go down here and use a rotation. Well, let's see what we can do here. Start with C. So we're starting with the big one. Aha. If we start with the big one, I can tell right away I have to shrink this thing. So I've got to do a dilation. Do that first. Let's mess with the size first, I say. And then you can go ahead and then spin, flip, slide, whatever you have to do. All right, since I am going, let's take a look at some of these points or side lengths, okay? In my original, these guys are 1, 2, 3, 4 units long, and these ones are 2 units long. The top was 1, 2, 3, 4. This top is 2. This is a little more challenging to measure because this has, I'd have to use Pythagorean theorem to actually figure this out, but take a look at what's happening. In order to make this diagonal, I have to vertically go 2 units and then over 1. And now I'm just going to go vertically 1 unit and only over a half. All right, so it looks like my dilation each time takes your original, and we take half of x, half of y. Now I was doing that just with side lengths, but you can verify this with some of your points. What's tricky here is that we also have an inverted image. So I'm going to kind of just take the leap of faith and do my dilation first. Take half of everything, would you? So instead of 2, 2, this corner up here, take half of both points and then we get 1, 1. This one, which was at 2, negative 2, will become 1, negative 1. This point down here, which is at negative 2, negative 2, will become negative 1, negative 1. Let me come up here. Negative 2, 2 will become negative 1, 1. Okay, now we got to scooch this guy in. This is at negative 1, 0, and this will now be at negative 1/2, 0. Cute! Got the little baby one there now. Okay, so now we've got to get this guy to look like this guy. Personally, what I would do is simply take this thing and just reflect it. They want us to use a reflection this time. So I would reflect it this way, which means reflect it across the y-axis. Now, think about what happens to your coordinates when you do that. This one ends up being over there. This one goes back over here. So these guys just kind of flip-flop. Negative 1, 1 becomes positive 1, 1. Positive 1, 1 becomes negative 1, 1. My y value stays the same, but my x value switches signs. That's what a reflection across the y-axis does. I don't shift vertically. I only flip things horizontally, so your x values switch. Test it with the other ones. That's what happens. Now, this is going to look crazy, but I've got to draw that picture on here and what it looks like. Okay? You've got the same four corners, but now your notch is this way. So I'm going to cover over that guy. Now it looks like this. It's the same exact size, and all we need to do is finally slide it up or translate it up, and you just have to count how many units. We're going to translate it up. Let's see. From this point, I go up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, from here, 1, 2, 3, 4, 5. Down here, 1, 2, 3, 4, 5. Yep, that's it. Up 5. So then you will take every xy coordinate. Not going to change the x value. You're just going to slide that baby up 5 units. Okay? Now, they may have gone along and done this in a little different order, but the effect is going to be pretty much the same. Actually, it looks like they did the dilation of 1/2, then reflected it, and then moved it up. So we're good. All right. Now, here's the deal. You could actually have done this with a rotation as well. If you would have started, let me erase all of my goobs on here for a second. If we would have shrunk it down first, just like we did last time, okay? So then you would have gotten this thing. Zoop, 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 zoop. Okay? And if you think of spinning it 180 degrees, then it would be positioned just like our reflection was, and then you'd slide it up again. Would have done the same stinking thing. Cool, huh? So you could have changed the size, rotate it, and then slide it up 5 units. Okay? So there's a whole lot going on in here. And here's what I want you to do. I'm not going to assign a whole bunch of these. All right. Here's what I want you to take a look at. And let's just skip off of that one and get into your guided practice ones. Okay. I would like you to do number 1. That's where you're kind of stepping through and going through this whole series of transformations. And this is what, page 330. Okay, page 330. Do that. Then I want you to take a look at all of these guys here. Okay. You're going to start with A. So this is the one you're always going to use as your basis. Okay. This guy in the middle that I've just goobed all over. And describe how you could get, and if you want, describe it in words, and then we'll talk about how to get it algebraically after that. But if you can figure out how to get there from A to B, how would you do that? Then go back to A. How could you get A to look like C? And then finally in number 4, how could you make A turn into figure D? You got all these cool, beautiful trapezoids to work with, all right? Okay, do those. And then the last thing I want you to do is number 5 on this page. So it doesn't sound like a lot, but these are super meaty, beefy questions on here. All right. So page 330, I'll scooch this up a little bit. I want you to do problems 1 through 5. Okay. And then what I would like you to do is if you get done with those, then I want you to get onto iExcel and I want you to just keep cruising through your checklist for the MCAs. All right. Whew. Awesome job. Here you go. Page 330, then iExcel. Work hard. And as always, may the force be with you.